In this session, we'll be working the problems in the Chapter 1 review, starting with Problem 1. Let's begin. Here we have a picture, we have a plane, we have a line in the plane, and a line intersecting the plane. So, first question, name a line intersecting the plane. Well, there you go. So, we have several ways to name a line. The first one is if there is a lowercase, usually italicized, but it doesn't have to be, letter sitting next to the line, we can name it with that. So let's start off here with problem 1. And the way we would name this is we would say line, the word line, and then the letter, in this case H. Now, another way to name this line is we can name it with any 2 points on the line. So we could say P, Y, and then we would put the line symbol over the top, which is a straight bar with 2 arrowheads. These arrowheads indicate that this object goes through Y and continues forever, and goes through P and continues forever. We could also flop these points, and we could call this YP with the line symbol over top. This is read line PY or line YP. Because lines go on forever, it includes either point, so it doesn't really matter which one we pick where. Okay, for number 2. Number 2 says name 2 rays. Well, we have several rays in this figure. We have ray YX, we have ray YZ, we have ray XY, XZ, YP, PY. So we're just going to name 2. So for number 2, let's put in ray, let's call it ray YP. And with rays, you have a straight bar with no arrowhead on the left and an arrowhead on the right. What this indicates is that the letter on the left is the end point of the ray, and the letter on the right is the point through which the ray goes and continues on infinitely. So ray YP starts at Y and goes on infinitely through P. Another one, we could say, let's just take ray ZX. So we'll have ray ZX. Again, we use an arrowhead going to the right. We always name rays with the straight piece on the left and the arrowhead on the right. The letter on the left is always the end point. The letter on the right is always the point through which the ray extends. Okay. Now for number 3. Opposite rays. Opposite rays are 2 rays that share a common endpoint and extend infinitely in the opposite directions. Here, the only candidates that we have are YX and YZ. We couldn't use YP because we don't have another point going the opposite direction. So, for number 3, we have YX, ray YX, and ray YZ. Okay, so these are opposite rays. And now finally, for number 4, name a point not in plane M. Clearly we can see that X, Y, Z, and N is in plane M. P, on the other hand, because it's on line H, which is intersecting the plane and going through the plane, it's not in the plane. And so since point Y is the point of intersection of line H with the plane. Point P is above the plane. So we would say, for number 4, point P. We always name points with the word point and then the letter associated with that point. It would be incorrect simply to say P. We have to name it point P. Okay, and now on to problem 5. In problem 5, our problem statement says find the length of xz. Whenever you see 2 points, 2 letters with no symbols over the top, you read that length of xz. So here we have segment xz, and it's made up of 2 pieces, xy, which is 17, and yz, which is 24. Now, this is using one of the first postulates we talked about in the chapter, and that is the segment addition postulate, which basically says that this larger segment equals this segment plus this segment. So xz equals xy plus yz. The segment addition postulate also says it talks about betweenness. It talks about the reason that y is between x and z, but that's not really pertinent to this problem. So for problem 5, we know that this segment, xz, the length of xz equals xy plus yz, which is 17 plus 24. Which is 41. Now for problem 6. In problem 6, we have a similar situation, only this time we have AZ is made up of AX plus XZ. So let's write down an equation. So let's put 6 here. And we know that AZ equals AX plus XZ. Now we can go ahead and fill in what we know. We know that AZ is 38. We know that AX is 27, so we can substitute that in, plus XZ. And this is the variable we have to solve for. So what we're going to do is subtract 27 from 38, which is 11. Okay, and now on to problem 7. In problem 7, we have an example of use of the distance formula. So it's asking us, find the distance between points S and T. So here we have 2 points on a coordinate plane, and we're looking for distance. Now it's not necessary to plot these points. You may be tempted to go ahead and plot the points and try to solve this graphically, but that would not necessarily be the best way to do this. Let's go ahead and start with the distance formula. So let's start out with problem 7. And the distance formula, distance equals the square root of the difference of the x's, which would be x2 minus x1, and we square that, plus the difference of the y's, y2 minus y1, and square that. Now, it doesn't really matter which point you pick as point 1 and point 2. It really makes no difference because we're squaring them and the signs are all going to work out okay. So let's just call this 1 and this 2. So we have it equals square root, that's a square root there, x2, 3, minus a negative 2. Squared plus, we go back to point 2, 9, for for the difference of the y's, minus 4. And we square that. So we have square root of 3 minus a negative 2 is 3 plus 2, so that's 5 squared, plus 9 minus 4, which is 5 squared, which equals the square root of 25 plus 25, which is the square root of 50, which when simplified gives us an exact value of 5 times the square root of 2, which is approximately equal to 7.071 to 3 decimal places. For information on how to simplify these radicals, see my video on simplifying radicals. Now I'm going to show you a different way to do this. And some people don't like this. I like it. It's a much cleaner method, I think. It takes a lot less time and there's a lot less rigor involved, but it's still the distance formula. So the way I do this is you take your points and you stack them one over the other. You take the x and the y, and then the other x and its y. Draw a line underneath and put a minus sign on the outside to indicate that you're going to be subtracting. Now this is going to be the distance formula. We're going to take the difference of the x's, because these are the x values and these are the y values. So difference of the x's, 3 minus negative 2 is 3 plus 2, which is 5. 9 minus 4 is 5. Now to finish the problem out, you only need to remember one little anagram, SAS. So SAS stands for square, add, square root. S for square, A for add, S for square root. And we have the exact same thing that we have over here, and you would end up getting the exact same result. So I think it's a lot quicker, it's a bit easier, a lot less writing, takes a little less time. But choose the method of your choice and have fun. Now on to problem 8. For problem 8, we're doing distance formula again, so 8, we get square root of difference of the x's, 6 minus 7 squared, plus negative 3 minus negative 2 squared, which 6 minus 7 is negative 1 squared, plus negative 3 minus a negative 2 is negative 3 plus 2, which is negative 1 squared. We take the square root of that. Now we have negative 1 squared, which is 1, plus negative 1 squared, which is 1, which is the square root of 2, which is approximately 1.414. Now let's do the same thing with the other method. So 6 minus 3, 7 minus 2, subtract 6 minus 7, negative 1. Negative 3 minus negative 2 is negative 3 plus 2, which is negative 1. And then SAS, square, add, square root, gives us the exact same thing as here, and we come up with 1.414. And now on to problem 9.